examine some more examples of areas between or among curves. The first one that is given to us is a straight line, 6 minus x, negative slope, minus 1, and g of x is 1 of x. So if we sketch this set of curves, we see that the first part of this curve is not relevant to us, but we're really looking for only in the first quadrant in the curve g of x 1 over x and f of x 6 minus x cross each other. So we have our limits in here is 0.172 and 5.8828. So the lower limit is the upper limit, and here's the area bounded by those two curves. So if we show accumulation here and show answer, so upper curve f of x minus g of x, and here we have for x equals so much, here is the f of x and here is g of x, subtracting and summing, we have total area on the bottom in here, and if you do this example at home, you may verify whether you have the same answer, 13.445 square units. Here is another example. In this case, we have curves opening sideways. One is a parabola opening sideways. We want to find the area bounded by those two curves, which is inside of those two curves. And if we show accumulation in here, so in this case we're going to be using horizontal elements, x of the right curve, brown curve, which is parabola opening sideways to the left, minus curve x equal y to the fourth, so x to the left is going to be y to the fourth, and the limit of integration from point of intersection here to point of intersection there, and the final answer would be, this is nice application for horizontal elements, and the final answer, total area bounded by those two curves, is 2.933 square units. In this example we have a straight line, and we have a second straight line, and bounded by the x-axis. So we're looking for a region bounded by x-axis in two lines. See if we show the graph. So we have this big triangle, which we can easily solve without integration, but in this case we're going to integrate. So using the one integral only, if we go with horizontal elements, if we were to go with vertical elements, we would have to have two integrals. And total area in here, you can easily verify using formula 1/2 base times height. Base is 6, height is 4, so it should be 12. Now in this example we're going to use the first quadrant in those curves, and you have a choice in here, either vertical or horizontal elements. If we choose horizontal elements, value of x coordinate of the curve to the right, which is the cubic function, x equal 2y to the power of 1/3, and straight line, and the answer of this one we'll have to find the limits by setting f of y equal g of y, and total answer is 2 square units. And we're looking only for the first quadrant, and that's very important. It's stated in the first quadrant, because otherwise we will have the same shape but mirror image twisted in the third quadrant. In this example, we'll have a straight line and parabola opening sideways. So if we graph those two curves, we'll have something on this sort, and we definitely would like to use horizontal elements, and the limits are easily found by setting f of y equal g of y. So 4 is equal y squared, so y is equal plus minus 2. And the lower limit is minus 2, upper limit is plus 2. We can integrate from 0 to 2 and multiply by 2, and we can get the same answer. And that would be enough examples just to demonstrate a typical examples.